Okay, so this is my video report on Lab 2 titled Computing Electric Fields in One Dimension. The main goal of the lab was to compute electric fields by adding up each and every single one of the individual contributions of different point charges along basically a line, a certain distance away from the edge. The problem we faced was that when you added more and more point charges along the line, the amount of work necessary to calculate the strength of the electric field became exceedingly more and more tedious as it went along. What we did for this lab was we started by working out some of these computations by hand using small amounts of point charges. Once we did that, we moved on to using the help of Excel to compute these calculations. We started by just recalculating the computations we did by hand in Excel and cross-checking to make sure our answers lined up properly. And from there, we moved on to using more and more point charges and finding out the strength of the electric fields with those, and then we ended up plotting the results. The main equation we used for this lab is E equals K times Q over R squared, with E being the strength of the electric field in newtons per coulomb, K being a constant, Q being the charge of the individual point charge, and R being the distance from the point charge to the point where we are measuring from. The results from this gave us, from part 1, it wanted us to, by hand, find the charge, the strength of the electric field using 1 point charge at a set distance away from the point from where we were measuring from, which gave us a answer of 1.47 times 10 to the 5th newtons per coulomb. Part 2 just wanted a simple equation for how you figure out the individual charge of each point charge. When you have more than one, which you would just take the sum of all the point charges, which was provided, and divide it by the number of point charges to get that. For part 2A, 2B, and 2C, we were just to do the same thing that we did for part 1, which was find the strength of the electric field at a certain point away, or find at a certain distance away from different point charges. For part 2A, there were 2 point charges. Part 2B was 3 point charges, and 2C was 4 point charges. And to get the answer, you would just sum up all of the individual charges, and that would be your answer for E. Part 3A, 3B, and 3C were just based off of 2A, 2B, and 2C, where we did it, instead of by hand, we did it using Excel, and then we just cross-checked our answers to make sure they did line up properly. For 2A, there was some problems with the handwritten calculations, but we were told we didn't have to actually redo them. But for part 2B and 2C, the answers that we got for those did line up properly for 3B and 3C. For part 5, it asked us what we observed after we did all of the calculations, because after in part 3C we then moved on to using 5 point charges, 10 point charges, 20 point charges, and 50 point charges. So it wanted us to explain what we saw based on the answers. And what I basically came to the conclusion is that the values for the strength of the electric field, or E, were coming closer and closer to 3 times 10 to the 5th newtons per coulomb, but it didn't look like it would ever actually reach it, which led me to believe that it was due to some sort of asymptotic convergence. And from what I understand, that's basically just where the specified value, in this case our E, acts as a horizontal asymptote, preventing our calculated values from ever actually reaching it, like a normal horizontal asymptote would do. After that, we then plotted our results. The plot on the left shows all the original calculations that we did using Excel, and then plot number 2 on the right shows the exact same calculations but using a different set distance away from the bar of point charges. Ultimately, we accomplished the original goal of computing electric fields using various quantities of point charges, using both hand written out calculus and also using the help of computations within Excel itself. We then plotted those values to show the relationship between the number of point charges and the strength of the force of the electric field. So yep, that's it.